Welcome. Obvious, my name is Dr. Mohammed. Today, I want to focus on the economics under application of calculus. Application of calculus. Remember that we have the differentiation and also we have the integration. In economic, you may apply the differentiation and the integration in the profit analysis. Maybe let's start with the first part. We have the total revenue. Total revenue, TR. Normally, for you to get the total revenue, we normally integrate the marginal revenue. For you to get the total revenue, you integrate the marginal revenue. But if you have the marginal revenue, for you to get the total revenue from the marginal revenue, you differentiate. Marginal revenue is equal to the derivative of total revenue. Then number 2, total cost, TC. Total cost is equal to the integral of the integration of the marginal cost. But if we have the marginal cost and we want to get the total cost, for you to get total cost, we normally integrate the marginal cost. But if we have the marginal cost and want to get the total cost, marginal cost is equal to the derivative of total cost. Now we can summarize that. We can say, let's say we have here the total revenue and total cost, and here we have the marginal revenue and the marginal cost. Now, if you have, we can summarize this: total revenue, total cost, marginal revenue, marginal cost. If you are given if we have the marginal revenue and the marginal cost and want to get the total revenue and total cost, this one we integrate. But if we have the total revenue and the total cost and we would like to get the marginal revenue and the marginal cost, we differentiate. If you have the total revenue and the total cost and you want to get the marginal revenue and the marginal cost, you differentiate. But if you have the marginal cost and the marginal revenue, you integrate. That's why we say the total revenue is equal to the integral of marginal revenue, and the marginal revenue is equal to the differentiation of the total revenue. The same goes with total cost. Total cost is equal to the integral of the marginal cost, while marginal cost is equal to the differentiation of the total cost. Now, I'd like to look at a simple illustration here on the board. Then we see how we can apply it. Here we have a farmer finds a marginal revenue given by the expression of 20 minus 2Q. A farmer finds marginal revenue given by the expression of 20 minus 2Q, while the marginal cost given by the expression 4Q minus 10. Its fixed cost is shilling 30. Q represent quantities of output produced and sold. Required. Determine the following. We have number 1, total revenue, total cost, and total profit function. Number 2, profit maximizing output, price, and maximum profit. Roman 3, break-even point. So, let's start with the first part. We are asked to calculate the total revenue. Remember now, we have the marginal revenue, and we say it here, total revenue is equal to the integral of the marginal revenue. Now you can say total revenue is equal to the integration of the marginal revenue. And remember, we are integrating the marginal revenue we have in the equation is 20 minus 2q. Remember the rules for integration. Whenever you integrate a constant, it will have the value x. That means now here we will have 20q minus 2q. Here we are going to add. Remember, if we are integrating, we are adding the power to 1. Remember, it was 1 plus 1, which comes to 2. Then we divide with the new power, which is 2. Now 2q squared divided by 2 comes to minus q squared. Since it was minus 2q squared over 2, these 2 and 2 will cancel. So we're only remaining with minus q squared. Now this is our total revenue, the integral of the marginal revenue. This becomes a, if you could have this total revenue and you are asked to calculate the marginal revenue, we could have differentiated this total revenue, of which here we could have, if we differentiate 20q, we'll have 20, then here will come to minus 2q. Number 2, the next was total cost. We say that total cost is equal to the integral of the marginal. We integrate the marginal cost. And remember, our marginal cost we have here is 4q minus 10. Now if we integrate this, remember here we are adding 1 plus 1, which is 2 over 2, which comes to 2q squared minus 10q. Whenever you integrate a constant, you will have the value x or q minus 10q. This becomes our total cost, 2q squared minus 10q. If you could have this our total cost, then you are asked to calculate the marginal cost, you could have differentiated this one, 2 by 2, 4q minus 10. Then the next thing is the total profit. Remember that total profit function. Remember that profit by is equal to total revenue minus total cost. You can do that this other side. Profit is equal to total revenue minus total cost. We have our revenue as 20q minus q squared. Then we subtract the total cost. The total cost that we have here is 2q squared. But remember, total cost includes the variable cost and the fixed cost. We normally add a constant. Whenever we are integrating the total cost, we normally add the constant. We add the fixed cost, and our fixed cost was 30. Here we could have said plus 30. Now, so that our total cost will have the constant 30. Now we bring it there, 2q squared minus 10q plus 30. Remember, this 30 was the constant k, the fixed cost. Now we collect the items. We open the bracket first. 20q minus q squared minus plus comes to minus 2q squared minus plus 10q minus plus minus 30. You collect the items. 20q plus 10q minus q squared minus 2q squared minus 30. 20 plus 10, which is 30. 30q minus 1 minus 2. Remember, there's coefficient of 1 before q. Minus 1 minus 2, which is minus 3q squared minus 30. And this is our profit function. This is our profit function. Now we are done with Roman 1. We show the total revenue, the total cost, and also the profit function. Number 2, we are asked to calculate the profit maximizing output, price, and the maximum profit. So we are asked 3 things here: the maximizing output, the price, and the maximum profit. We can do this in 2 approaches. I'm going to show both of them. First, for us to get the maximizing output, we can get it in two ways. We can say at maximum profit, you can say the derivative of the profit is equal to 0. Or we can say marginal cost is equal to the marginal revenue. Let's start with this derivative of the profit. Let's start with the first one. We can do in these two approaches. You can use the derivative of the profit, or you can equate the marginal cost with the marginal revenue. If I start with the derivative of the profit is equal to 0, it means, and remember my profit is 30q minus 3q squared minus 30. So if I differentiate this one, if I differentiate 30q, remember here we are differentiating, we are multiplying the power with the coefficient 1 times 30, which is 30. Q 1 minus 1 raised to 0. Any number raised to 0 is 1. So this number will remain as 30 minus 3 by 2 is 6. Q 1 minus 2 minus 1, so we will remain with 1q, 6q. Whenever we differentiate, the constant is 0. So you can say it's equal to 0. 30 minus 6q. So you can say 30 is equal to, we bring the 6 the other side, 6q. For us to get q, we divide 6. So q is equal to 5. Now we have used the derivative of the profit, but we can also equate for us to get the maximizing output. We can also second part where we can equate the marginal cost. Marginal cost is equal to the marginal revenue. Remember, from the question we are given the marginal cost. The marginal cost that we have been given 4q minus 10. 4q minus 10. Then we equate the marginal revenue. The marginal revenue have been given the 20 minus 2q. 20 minus 2q. We equate the right term. So we'll have 4q minus 2. If you come this side, it will be plus 2. Q is equal to 20 minus 10. If it crosses, becomes plus 10. So we'll have 6q is equal to 30. We divide the 6. Q is equal to 5, which is the same as the approach we use with the derivative of the profit. Now you can use whichever you want. But remember, sometimes one method may be possible. Maybe you don't have the marginal cost and the marginal revenue, and the only possible way is the derivative of the profit. But if you have the both, you can use only one. You don't have to show the both. You only use one. Now we are done with the maximizing output. Q is 5. We are told the price. Remember, we are having the total revenue. When we differentiated the marginal revenue, we get the total revenue as, we got it as 20q minus q squared. But now we know q is 5. Before that, we are asked to calculate the price. And remember, price is equal to total revenue over q, which is 20q minus q squared. We divide with q. This q cancel with this q will remain 1q, which is equal to P is equal to 20 minus q. But we know q is 5, so P is equal to 20 minus 5, which is equal to 15, which comes to 15. We also ask the maximum profit. We know q is 5. And remember, our profit function was 30q minus 3q squared minus 30. But we know q is 5. Now we substitute with 5. 30 into 5 minus 3 into 5 squared minus 30. 30 by 5, that is 150. 150, 5 squared is 25. 25 by 3 comes to 45. So 150 minus 45 minus 30, which comes to, if you subtract 150, you're able to get 45. You're able to get 45. Sorry, 5 squared 5 squared is 25. 25 by 3 will not give you 45. It will come to 75. 75 minus 30. So if you subtract 150 from 75, you're able to get 105. 105 from 30, you get 45. So here 5 squared by 3 is 75, not 45. You correct that. Now our profit is 45. Our profit is 45. Lastly, we ask about the break-even point. The break-even point. Remember, at break-even point, you say at break-even point, profit is equal to 0. Not the derivative, but the profit. And remember, our profit function was 30q minus 3q squared minus 30. Now we equate this to 0. But remember now, this is a quadratic function. It's not linear. If it was linear, it was easy to calculate. But these are quadratic equations. And we have several methods of solving quadratic equations. We use the cumulative square method. We use the formula method. Me, I like to use the formula method. So the formula is negative b plus minus. We take the square root of b squared minus 4ac over 2a. This is the formula method. And remember, a is the coefficient of x. For our case, the coefficient of q. For our case is, x squared. A is the coefficient of x squared. For our case, it is negative 3. Our x represents the q. Now, the coefficient of q squared is our value for a, which is negative 3. B is the coefficient of x, which is the q, which is 30. Then the c is the constant, which is negative 30. Now we can say our a is the coefficient of x squared, which is negative 3. B is the coefficient of x, which is 30. C is negative 30. Now you can substitute it here. Remember, b is positive minus, which comes to minus. So we say minus 30 plus minus square root of b squared minus 30 squared minus 4ac. 4 multiplied by a, which is negative 3, multiplied by c. Our c is negative 30. Then we divide it with 2a, and our a is negative 3. So we take negative 30 plus minus. If I take 30 squared, which is 900 square root of 900 minus 4 by negative 3 by negative 30, which comes to 360. Then we divide it with negative 6. 2 by negative 3 is negative 6. Now if I take the square root of 900 minus 360, 900 minus 360, then I get the square root of the answer, which comes to, now I get negative 30 plus minus, the square root of this is 23.24. Then we divide with negative 6, since it is 2 by 3. Now, our first value, Q1, is equal to, we take negative 30 plus 23.24, we divide with negative 6. So if I take negative 30 plus 23.24, divided by the answer divided by negative 6, I'm getting 1.13. The second Q2 is equal to negative 30, now we minus 23.24 divided into negative 6. Negative 30 subtract 23.24, then divide the negative 6, getting 8.87. That's all about this illustration. You have to remember that we have the differentiation and the integration. Whenever you have the total revenue and the total cost, for you to get the marginal revenue and marginal cost, you differentiate. Marginal revenue or the marginal cost, you differentiate. If you have the marginal revenue and the marginal cost, and you like to get the total cost and total revenue, you integrate. Lastly, when it is break-even point, you don't differentiate the profit. We just substitute the profit to 0. We don't differentiate. But when it is maximum profit, we differentiate. The derivative of the profit is the one which equates to 0. But the break-even point, the profit itself before differentiating is what we equate to 0. That is all about this illustration. I hope you enjoyed the class. See you next time.